float or character. So now if I wanted to do that, dash include studio.h. Okay, so simply as include studio.h. Okay, so let me write a function, generic function for different data type, print value. Okay, so let me okay. So here, let me go here once again. So print value now void. So void star pointer. So what do you mean by void? So this pointer may be pointing to integer type, character type, or float type, or anything. So for that, we are using a general term called void. Let me type some character type I am passing here. So this is the function. If character type char, that is nothing but type, is equal to I, that is an integer type. So now what I can do is printf. Since it is a single line, I do not require to use bracket. If you want to use, then you can use it. So integer, and %d. Okay. So I am going to point to the,
Excuse me, sir.
yeah.
Sir, you are not able to see the screen share.
Now can we?
Yes, sir.
So now if I want to see here, there is a white pointer of character type int ptr. So now this is done. Okay. Similarly, if I want to use else if of type, okay, float type. So then printf, okay, we have float percent 0.2f. Okay, new line. So here it may be a pointing to the float pointer. Data type we have to cast, because this is how you can cast it. Similarly, if I wanted to type C character, then printf character C, new line. So chr star ptr. So we have, let me close this. So this is how we can. So this pointer ptr, instead of writing three functions, one is for int, one is for a float, one for character. So I can write like this. Okay. So then let me void main. Let me write this int num is equal to 10. Float pi is equal to 3.14. Char letter is equal to capital A. Now if I want to print these values, okay. So what I have to pass for integer type, I have to pass the num. What is the character type? I. So then it will be rightly pointed. Similarly, if I want to so here print value. So this may be by address because a pointer of wide type. So another one receiving it. So letter. So this can be F and this can be C. So then let me write get CH. Okay. So here I can write clear screen and I am calling this function. So let me save this. Let us run this. So you can see that integer value 10, float value is this one, character. So what I have done? So pointer is the specific to the which data type. Instead of that, can I generalize it? Yes, we can generalize. Otherwise, the print value we have to write like this, right? So if I really control insert. So for one is for int, like this I have to write actually. Then this should be removed. Okay. And this should be removed. So like this, instead of writing multiple functions, I can write a one generic function. And for generic usage, we have a concept of the wide pointer. So wide pointer can be helpful. So this is how we can use the wide pointer. So that means we have understood what is null pointer and also what we have understood what is wide pointer. So this will be helpful for flexibility purpose actually. So next one is, so if you, when you talk about is a wild pointer, so wild pointer is nothing but avoiding the uninitialized memory access, right? So like declaring a pointer without initializing. So that is the meaning. So let us just understand that. So because these are the four, sometimes we tend to do a lot of mistakes when we are using the pointer. So that's why we are trying to this one. Usually, like without initialization, if I use it, okay, that is a wild pointer. So let us do that. Let us save as. Let us open. Okay. So let me. So let me take one example. So wild pointer, right? Wild p pointer, something like this. Let me take this. Usage without initialize. So that's called as a wild pointer. Okay. So majority of type embedded systems, people tend to do this mistake, and this is a unnecessary uninitialized memory access. We are trying to do that. So that is what we call it as a wild pointer. So when you say wild pointer, that is nothing but wild pointer. So now let me go here. Ash input studio.h. Write mine. So let me write int star ptr. So here, this is the wild pointer. This is wild pointer. Actually, if you try to print this or use it, printf %d new line pt star ptr value you wanted to print. This is actually wrong things because it is we have not initialized even null. Okay, null pointer also we have not. So this type of mistakes, if you do it, okay, then instead of that, okay, I can say that int num is equal to 100, ptr is equal to ampersand num. Now if I printf, if I do this, value is %d. So star ptr, this is the right approach because at least we have initialized this value. So, but this is the wrong approach. If this is used, this is pointing to nowhere. Here we have initialized it. Now, if you run this, so it should print 100. So it is printing. Value is equal to 100. Previous value it is showing. If you make it clear screen, automatically it will work. So value is 100. So you are able to do this. So that means we have understood three different types of pointer. One is wild pointer. We have understood without initializing. If we use, that is called wild pointer. Usually we have to initialize it. Another pointer, what we are talking, void pointer, irrespective of data type. If you want to generate void, and null pointer, so you have to initialize with a null, the keyword, so that you can able to do that. So another important pointer we are talking about is majority of time when you're writing the data structure algorithm program. So we will be doing certain mistakes. So that is what we call it as a dangling pointer. If sometimes we get a message that, okay, you have used it, but after that you freed it, but once again you wanted to use it. So that is called, which is not available in the scope itself and you are trying to access, okay. So that is called dangling pointer. So this is the common the basic error we used to do whenever we are working in the data structures and algorithms. So let us see that as well. So that you can have a better idea. So let me go to the dangling pointer. Okay. So let us try to see this. So now let me understand dangling pointer. So dangling pointer is nothing but after free the memory trying to use. So this will create a dangling pointer. Let us try to do that. So hash include studio.h, hash include conio.h. So now, so int main. So now if I write, okay, assume that usually if I want to allocate a memory, so we have three different concept. One is malloc, calloc, and realloc. Okay, so just I am taking malloc, but anyhow I will come back and discuss. Next, let me write in a bank. In a bank, I have a balance. Okay, and it is pointing. It is a pointer for me, balance pointer. So whenever you are using normally, so we will be declaring properly type integer pointer. So malloc, so integer value it will be holding. How much size? Okay, so that is nothing but size of int in this machine. So that much memory we are kept. Okay. Now, so if I wanted to, memory is allocated to hold the value of balance, which is of integer type. So malloc is nothing but it is a memory location. In the heap memory, it is trying to allocate it may be 2 byte or 4 byte, okay, memory it will be allocated of type integer, but it can store only integer type value. So just to this line is to used for allocation of memory before usage. Now, once this is done, let me write balance is equal to 5,000. Some amount I am adding. Okay. Some amount I am adding. I will be printing this. Printing balance is Okay. So star balance. We have done this. Now, so let me get CH. So till this time, no issues. So it is showing balance is 5,000. Now assume that, okay, whatever the memory allocated, I will be going to remove this. So this pointer, I'm going to remove this. This is nothing but I am given back the heap memory, free the memory, assuming that I will not be using it. And suddenly, if I want to use this, okay, once again, if I try to print the same, shift insert, or pointer balance, so free, right? So free, memory is freed. After that, if I try to use it, it is a dangerous pointer because once it is freed, it means that it can still another value. So now 5,000 is disclosing because in that memory, some garbage value is there. But it can be anything there actually. So it can be any unpredictable value. Okay. So balance. So any unpredictable value can be there. Okay. But actually we should not use after this. If you try to free that, after that, if you are printing, it will not print the previous one. It is unpredictable value. So this is dangerous actually. So this type of once you use the free and remove the memory, means you are free from our data structure. This malloc, whatever the memory is allocated, it's removed. Then if you try to print it, so this is nothing but the dangling pointers. So this is the another type of pointer. So please avoid this because majority of time in the data structure programming, we face this type of problem. So this is what we have to understand as a part of dangling pointer. So that means we have understood there are 4 different types of pointers. One is wide, wild. Okay, we have understood. And also we have understood the dangling pointers. So there are 4 different types of pointers. So with this note, we have understood all these things. So null pointer we have understood, wide pointer we have understood, and wild pointer and dangling pointer we have understood. Now, if you look at this, okay, so this is just a understanding we have already discussed, I think, okay, in this one. But if you look at here, okay, once again, the memory layout. So when you try to do any programming, the local variables and block, control flow, everything will present in the stack, okay, and this will grow downward. And there is a concept of dynamic memory, that is what we are talking about to data structure. So this is called heap memory. This is grow in this direction, this will grow this one. And this is dynamic part. This is dynamic part. So usually we are working on this area. Okay. When you are doing this in C programming, so you have to explicitly tell that, okay, explicitly tell that how much memory size is required. To explicitly tell that we have concept of malloc, calloc, realloc, and free pointers are there. So malloc is nothing but like allocates uninitialized memory. Okay. It is initializes, calloc initializes is to the size, but also it initializes to a 0 value. Okay. Realloc is nothing but you have a memory, but you have used it. But at this moment, you can enlarge it. If, for example, initially you are using 4 bytes, suddenly you need 8 bytes. So then you can go and add some more 4 bytes so that earlier data should not be lost. This is called a realloc. And after usage of all these 3, and I can free that's called a free pointers. So that means in the memory, if you look into that, so we are targeting here to work here. And these are the different types of memory management in C programming. So usually that is called heap. So stack, it is stores the local variable and function calls. Heap, dynamic memory allocation. Malloc, allocates uninitialized memory. Calloc, zero initialized, realloc, resizes allocated memory. Free means freeze the do that. If you do, if you have any issues, okay, do certain mistakes when you are coding using this memory management, it leads to the memory leaks, dangling pointer, and invalid access. These type of challenges you may face it. So that's why better understanding of this memory management is more important with respect to your pointers. The first part we wanted to discuss is malloc. So what is malloc? Malloc is nothing but your name itself, memory allocation. What is M means memory, alloc means allocation. So memory allocation is a function dynamically allocates memory at runtime from the heap. It is a part of standard lib.h library. So using that we can do that. So we have to use this syntax pointer cache type, whether integer type or float type or double type, you have to tell explicitly. Malloc, you have to use this, the predefined keyword, then you have to pass the function. So this size. So function, you have to malloc and it will accept the argument. What is the, how much size of memory you require to point the integer type of value, float type of value, character type of value. So this is how it will be there. Okay. For example, if you don't try to get the memory for usage, then it will give the null actually. Okay. And if we cannot use before without initializing the value, if memory is allocated, then definitely you can start using. If you look at this, for integer type, int star p is equal to data type of return type is integer because it is pointing to integer value. So malloc, how much size? 4. Size of integer, if it's a 4, 4 into 4, 16 bytes of memory is allocated to hold the integer type of value. So then only you can start using dynamics. This is called as a dynamic, the heap memory usage for our data structure. So this is how we can do that. Let me go and do some coding after this, okay? And we'll try to understand. Similarly, we have this is memory allocation. This is a contiguous allocation. Okay. Here, C allocation is there is only one difference we have is okay. Here, okay, it is not initialized to a 0. This memory location 16 bytes. It is not initialized to 0, but here it is initialized to a 0. And also here it is only one argument. Okay, 4 into 4, 16 bytes of memory. But here will tell you how many blocks of contiguous memory. 4 blocks, 1, 2, 3, 4 of type of integer, each 2 bytes. So contiguous block, 4 blocks of 4 bytes, okay, all allocates dynamically. So this is the difference between malloc and calloc. Both will allocate the memory, but this will be initialized contiguous allocation in terms of blocks, block 1, block 2, block 3, block 4, 4 blocks of size of int is 4 bytes. If memory is available, it will be allocated. This block to the 16 bytes is allocated in terms of contiguous allocation. This is called the contiguous allocation, the other way of the initializing the memory in the heap, okay, and for the further usage. So here void star calloc size of int plus a number and size of what is the size. So it accepts 2 argument. So this is called contiguous allocation. Okay. And then finally, so free is nothing but, okay, if you want to free it, so you have to use the free function, whichever the free of p, that means the memory allocated will be no longer is usage for the current program. It can be used from anyone. Okay, free function is used to deallocate a memory that was previously allocated using malloc, calloc, even realloc. Okay, prevent the memory leaks by releasing dynamically allocated memory when it is no longer needed. Whenever no longer is needed, just go and free that pointer. Okay, so that automatically you people, that memory will be used for some other usage actually. So another last part type of memory management we are talking about is realloc. Okay. Why realloc is required? Suddenly you are using the 4 bytes, assume that integer this one, and in between you will come to know that I need further additional memory. So that means we wanted to resize it, okay? Resize the allocation memory. So memory allocation, okay, contiguous allocation, then this is resize allocation. So that means existing size of the memory will be increased to the next level. So here realloc, P is the pointer, okay, pointer to this, the already allocated memory into how much size you wanted to increase. Earlier 16 bytes, once again I am increasing to 16 bytes, 32 bytes. But earlier data will not be lost, okay, that is most important here, and old data will be retained and memory will be extended. So this is how the realloc will be used without losing the memory location. So we can expand it. So some situation it may be needed. So that is why they have introduced the realloc also. So that means there are malloc, calloc, and realloc. To free the memory locations, we are using these things. So if you look at the difference between malloc allocates single block of memory, calloc multiple blocks of memory, and reallocate resizes the previously allocated memory. So initialization does not initialize memory, okay, whereas in malloc, but here all the elements to be elements should be initialized to a 0. Realloc is retaining the old data. So that is this one. So here pointer type malloc size, here number of blocks and size. Okay, realloc is nothing but pointer to the old block and new size. So this is the difference between these things actually. So also all are white pointers only. That means you can point to any data type. So that is what you have to understand. Based on the typecasting, the corresponding pointers will be allocated. And a single contiguous memory malloc, whereas it is the multiple contiguous memory, it attempts to expand existing block. So use cases, so allocating memory for single entity, it is for multiple entity, and dynamically if you want to resize, you can use it. Since it is a single block, okay, it is a faster, malloc is faster. Multiple blocks, calloc, so that's why it's slightly slower than this, okay, because it is initialized to 0 also. But realloc, it depends upon the how it is copying to the new block. So that is why realloc is there actually. So usually the realloc will work. So it will take, if you assume that earlier 8 bytes of memory was there, and suddenly you want to extend to 16 bytes, it will copy the data to the another memory location where 16 bytes are available, and also size will be increased. So that's why the performance will be always lower compared to these two. So that means we have understood what is the difference between malloc, calloc, and realloc. Let us do also one or two programs just to understand this concept, because in the data me go here. Let me go here, open. I've done this. So let us understand malloc operation. So now I should include studio.h. So let us understand how to use memory allocation. So dash include audio.h. Now int main. So here, as I said, so malloc can be pointed to the any data type int star ptr. Okay, it is a void. So whichever the pointer you have data type you are pointing, malloc size of int. So this allocates the size of memory. So now if I want to, if ptr is equal to null, It means that much memory is not available in the heap. So then you have to give the printf memory is memory allocation is failed. If memory is not there, memory allocation will be failed. Return 1. Okay. If memory is available, star ptr. So only you have to initialize with integer value. Printf so here star ptr. So once this is done, if I want to free this, so I will return 0. If you look at this, okay, so this is how we are allocating a memory. So let me clear screen. So control. Control. So better. Let's ch. So value is equal to 100. So this is how so we can assign the value. So we are able to understand how to allocate the memory. So this is how we have done. Okay, malloc means memory allocation, and before usage, this pointer we are allocating a memory and we are using it. So this is what we call it as a memory allocation. Similarly, if I want to use alloc, okay, or something, if you want to realloc, okay, how to do that? We can do that. So memory we can initialize. Even if I want to initialize here only 5. If I want to initialize to the number of blocks, for example, let me write. I want to increase dynamically. Let me do that. So now what I will do is store the, let me write, for only one value. Instead of that, I wanted to initialize I less than n number. N can be, let me initialize how many blocks? 5, okay, 0, I plus plus. So here, printf, sorry, first I will assign this. It is a pointer to an array. Okay, a pointer to array. Okay. So here I will, instead of allocating size 5, I will allocate how many pointers? So let me copy this. Control insert, control KK. Okay, so here. So here I will make this as pointer to null, not pointing to any value. So here I am dynamically allocating how much size? N. So that means 5 into size of it, 5 numbers. Now, so PTR, okay, I is equal to I plus 1, some value I am storing. Okay, and then if I want to print this value, instead of 100 now, I wanted to print these values. Control insert. So here I am printing the values. So I0 is 1. Here printf %d ptr. So now if I want to free it, get ch, we can do. So what I have done is very simple program. Instead of one block, so I have taken, so ptr is equal to null. I can see that memory is not available. So if it is available, so let me just, I have to do it before this. So here, after clear screen, just I am checking and initializing this much memory is available. That means 5 into size of int. Okay, that much many size. It is an integer. For my machine, maybe 2 byte or 4 byte. So that much memory is available. Then if it is null, that means it is not possible. So we will return from here. Otherwise, I am initializing the value for this pointer. So then I am printing the pointer value. Now, if I run this non-pointer, it is integer only, right? Pointer. Integer. Star ptr. So sorry, here pointer to pointer. Okay, not this. Expression syntax. So okay, I is equal to 0. So it should be declared here. So I have done. So 1, 2, 3, 4, 5. So why this is available? So if you look at this array can be, it is nothing but, if you have a confusion, this is as good as so because of this, it is printing. So if you 1, 2, 3, 4, 5. So that is, so instead of representing like this, so actually array means like this one. Actually speaking, array means plus I. So we have 2, 3, 4, 5. So that's why it is printing actually. Okay. So if you look at this, what is this malloc is doing? Malloc is doing is just it is taking the memory and it is initializing the n value. And then after that, we are initially malloc will initialize to a size of 2 bytes, 5 bytes. It is a single contiguous memory we required. So since we are taking a 5 block, so we have done this. If memory is available, so then it will proceed here, and we are initializing for each block of value. We are reinitializing and printing. So this is how we can dynamically point to the n block of size of memory. So this is how we can work on malloc. Similar to that, we'll see on calloc and as well as realloc in the next session, so that you can able to and appreciate how memory management dynamically work, which is prerequisite for the so when we start the data structure. So without this, we can't understand the what is called the data structure. So these are the pointer concepts, probably 2-3 sessions where we will try to understand explicitly pointers, okay, with various all kind of possibilities, so that you will be comfortable when we learning the data structure. So thank you very much, whoever is on the YouTube live. So thank you. Thanks a lot.